So everybody at home, please sending some gift or something because they're really nice to you and helping me. Applause, applause, you're right. Okay, so the next question gonna be what?
Cash would be better.
Okay, so just let's do it really simple. And the next question gonna be about superposition. Okay, so I'm gonna deal with charge right now and forces and the stuff in the class. So if I'm gonna have this system and I have a rope, the rope starts here and ends here. This is my rope. Okay, and the rope starts with L over 2 and end at 3L over 2, and the total length of this is L. You see? Okay. And this thing is charged by some Q. Somebody come, touch it, put electrify it, put some charge on it. And here, somebody come and put a point charge. Here it's also with the charge Q. Okay? So what we're seeing in physics that if somebody has some charge and emit other person with charge, they're going to attract or repel each other. Okay? So this is Coulomb's law. But before we're going to dive into it, I want to ask you, like before, what is the charge density of the rope? Can you tell me that? So first of all, what kind of charge density? This is linear charge density. It's going to be linear charge density because I have only the unit x. So the question is, what is the linear charge density? And I tell you it's uniform. So if it's uniform, all I need to do is take the total charge, Q total, and divide it by the object, right? The length of the object, which is L. And that's it. You found it. The first thing, section A, done. Easy, peasy. Yeah.
What Q dot total is going to be like there are two charges going on in this system,
yes,
right?
but how many charges do you have on the object, on the wire?
One.
Only Q. This one is a point charge somewhere else, right? Actually, it's L over 2 far away from the end of the rope, right? Of the wire. Okay. B. Question B would be to ask if you're gonna cut this, this. Look, just observe, dq, small dq. What's gonna be the force? The dq gonna apply on this particular charge. Okay, so the question is, what is the force? dF, small unit of force. This dq, the dq apply on the unit charge, not the unit charge, sorry, the point charge. That's the question. Okay, do you remember the equation for the force, Coulomb force?
Q.
Nice, okay, so this is equal to K, nice.
Q1, Q2.
Q1, Q2, so we need to understand which is Q1 and which is Q2. So the rope actually have this one, this small, let's do it on red, so you can see it. So this small one is actually dq. This is the charge that this part of the rope presents, right? And we have this thing, right? Q, so I put here Q. And what is the distance between them? The distance between them is, I can say it's x, right? If I say this is dq at the place x, right? At the place x. And I actually don't need to write the place x because they're all the same, right? Because it's a uniform charge density. If I'm here, this is the charge. If I'm here, this is the charge. If I'm here, this is the charge. It's uniform, okay? So K dq, Q, and distance between them is x. X what?
Square.
Square, perfect. Okay? And also, they have the same sign, right? Right? They have the same sign. So I also know what? The direction, right? So it's going to push it where?
Left.
Left. Okay, left is in the math language is?
Negative X.
Negative x, exactly. Okay? So we actually know that's it. We found it. Okay? And now we're going to ask what is the section C? What is the total force that the rope applied on the charge, right? What is F rope? Let's call it wire, wire on this ball. So the whole equal to the sum of its parts. It's the same. If each piece of charge that connected to the rope is actually pushing the ball, I need to sum all the contributions of all the small pieces that want to push the ball. This is how much each one pushes the ball. So this one is equal to integral of this one, df dq on the ball, right? And this is a vector and this is a vector. Now let's put this one here. So the integral push k dq q x squared, right? And I'm gonna say it's in general the all point pushing to the left. And we didn't finish. We didn't say what is dq, right? Let's say what is dq. What is dq equal to? This is tutorial 1.
Gamma times
The length. Gamma 0.
Lambda.
lambda, yeah.
How are we gonna divide it? To what? To what section? I need the line in it, right?
DL.
Huh?
DL.
DL probably, but look at this. Yes. Even simpler, right? Okay. So this is actually, let's put it here, integral k lambda 0 q x squared and dx, right? And what I need to finish this integral, I need something that is really different than math.
The limits.
I need the limits. I need to say where this rope exists, where this charge ends, and when it starts. So where is the rope start? Where I see the first dq, L over 2, perfect. And where is gonna end?
3L over 2.
3L over 2, perfect. So now it's a closed formula. We can solve it and we can actually know what is the force. Okay, so I'm gonna move to the other board. Let's finish calculating. Okay, perfect. And so the integral, this integral, if you're gonna take it, it's gonna be equal to f this force is equal to 4 over 3 k q squared L squared minus x direction, because all the small pieces contribute to push the point charge to the left, right? So this is the answer. Okay, perfect. Now I want to do something really nasty. Okay, go back to this board. I want to add another point charge, and it's going to be located here. And I'm going to give it massive amount of charge. Okay, I draw it bigger, but it's not have to be bigger. Okay, it can be the same size, but with more charging, right? Okay, so every time you're actually touching a doorknob, maybe there was a charge that you transferred to the node, but it was so small that you didn't feel the pain, right? So every time, it doesn't matter how big you are or small you are. Of course, if you are big, you have more space to accumulate charge. And we're going to talk about that in another chapter.
Why is it q squared?
Why it's q squared? Because you had here this, right? We substitute, it was a good question. He said, hey, dude, where did you give this q? Another q, because it's q squared. And the answer for that, guys on Zoom, it's your time. Okay, so be with us and tell us if we don't see you, and you don't see us. Okay. So q squared is because we have also q from the linear.
Right.
Linear equal to q. This is the reason q total. This is the reason you actually have this here, right? Yeah.
Ron, like you took q total to be q, like they're the same?
No, I just okay. They are the same because it was a given.
Oh,
okay. Specific in this question, they do have q and q. The rope in general had q, and the point charge was the q. And now I did something nasty. What I put
point charge.
Another point charge here, and just from intuition, what it's gonna do to the charge? It's gonna push it, right? Push it hard. Okay. So the question that I got to ask you is there, and this one also going to push it, right?
Yeah.
Let's do it red. And this red wire, let's do it all red. gonna push it also, right? Is there gonna be a place? If we're gonna put this for you, this point charge will not move.
Yeah.
Yes, there is some. It's when these two are gonna cancel each other, right?
Yeah.
So the question to you is, what is this distance? Okay, let's find out what is this distance. For doing that, what we need to do?
Superposition.
Superposition, perfect. I'll go to you. Da 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 da. The superposition shirt. Okay, catch it? Not really, bring it back. Okay, so and just for this, this is your trophy for the answering right. So okay, so we need to do sigma f equal to what? To 0. That's what we want. We wanted the ball actually gonna stay in place. Why 0? Because it's n multiplied by a, and we say it's not accelerating to anywhere. Stay in place, it's 0. Okay? And this is building from two forces, right? Superposition. The first one is
From the wire to
the wire, which we found it, right? Is this is the wire, is F wire to the ball. And the second one is the big ball, the big ball to the small ball, right?
Yeah.
This is what we have. And we're gonna say they're equal to 0. Of course, they're gonna be directing to opposite directions. Let's go back to this board.
So like the sign won't matter, right?
The sign will matter. Let's find out. We expect it to be plus, right? Let's find it. So what is actually the force between them? What is the blue arrow? Let's do it blue. F for Q pushing small q equal to, it's a vector, start with K, and for Q, that's the guy, multiplied by Q, the original one, divided by the distance that we want to find. Good, so we are in the right direction. Square, and what is the direction? It's pushing it to which side?
Towards the right. Positive x.
Positive x, exactly. Okay, so we found this one. We need to say that they are equal to each other. What's happened actually? This one is positive, this one is positive, this one is negative, so I take it to the other side and it changes its sign to positive, so I can compare between them. This one must be equal to the red wire, which is 4, 3, K, Q squared, L squared. What I see the Q falling out, Q falling out, falling out, falling out, K dying out, K dying out. I still have this D, so I multiply by D squared, multiply by L, 3 squared, take a root, right? I can take root of each side because I do it for both of them. If I'm going to do it to one side, it's not going to be even. I need to do it to the same. So D is square root 3 multiplied by L, and we found D. Perfect. Okay?
I have a question.
Go ahead.
That session that you found the force from 4Q to Q.
Yes.
Okay, so when we are putting the charges, the K1 and Q2, we should put them
K and Q1.
Yeah, okay.
Q2, yeah.
We should put like, because the force that's 4Q is also on the Q, it's -4, and the other is also minus Q.
Correct. You see, that's what I did here.
And then you put, and then the minus cancel, and then
No, there's no minus. Both of them positive. Okay.
the charge is positive.
The charge
Okay.
of both of them positive. Maybe I should, emphasize
Think
that.
about direction instead of
Yes.
charge.
You know the direction because you know that the sames repel each other, and different charge, different polarity attract each other. That's a rule you need to remember. Okay? And so that's it for today. What I want you to do for next time is see tutorial number 2, all the section of tutorial number 2. And we're going to meet on Monday to do hard questions from exam regards to the same subject. Okay? Okay? Perfect, guys. Thank you. If you have a question, you can also ask me after the class. Just stop the thing. This, I'm going to stop the video here. Zoom people, you want to ask something?
No, thank you.
Okay, bye. Have a good day. Have a good one.
Thank you. Bye-bye.
See you soon.